Hi, I'm so sorry, but could you do social distancing for two of us? So, okay, okay, got it. Yeah, but yeah, in the class time, please sit in here. Hi. Pardon? Ah, okay, no problem. Yeah. Great.
One 125.
Since it was like
Okay, howdy. Yeah, nice to meet you. So as always, we have a quiz on this coming Thursday, which is quiz 5, and it will be updated on website. And next week, we will have a quiz for video. So again, you can upload your video on YouTube or anything else, then share the link for me, then I will check it for, next week. But in this week, we will have quiz in website. So this is one announcement. And the other announcement is that there are some students who worried about the grade on exam 1, and they want to recover their grade. But yeah, but what I wanna recommend you to is just solve your homework problem again, especially for preparing exam 2 and 3 and 4, because this course is not the comprehensive course. So it means that exam 1 topics are very different from exam 2 topics, and exam 2 topics are different from exam 3 topics, and so on. So even if you work on the exam 1, but it doesn't help you to solve some problems in exam 2. So if you want to prepare your exam 2 effectively, then the first thing I recommend you to do is just solve the problems in the homework perfectly. So even if you got the low scores, or your extension homework is passed, but your due date on homework is just passed. But in that case, please let me know that, or please ask me to extend your due date, or please give me more chance to solve the problem, so that I hope you can understand perfectly on the every homework problems, and it will be definitely helpful for you to prepare next exams, right? So, and I'm generous about such your extension or such your giving you more trial on homework. So please ask me if you need, right? So that's my unofficial announcement. Okay. Do you have any question? Okay, so let's start with the next chapter. Okay. So quiz 5 is about the chapter 5. And this chapter 6 we deal with. So it is from last Thursday and today. And there is some question from Karen that what will be the password for the quiz? I didn't set it right now, but I will let you know. Yeah. Or can you go over example 944 and 945 from chapter 5? Okay, then let's deal with the example first before going next chapter, because I think these are the most difficult example you deal with. Thank you, Dawson, for question. Okay, so here is the example 9.4. So amount of time students spend studying on the Sunday is normally distributed with a mean of 145 minutes and standard deviation of 23 minutes, right? So here, when you have some mean and standard deviation, just let it as mu and sigma for each one, because we don't know we don't know about the first portions in the normally distributed line, but we already know about the standard normal curve, which has mu is just 1 and sigma is just 0. So we will change it as a standard normal curve and using G-score, then figure out the percent, right? So the first question is about what is the range of start times that makes up the middle 95% of the students? Pardon? Do you have any question? Okay. So to figure out the middle 95% of the students, all we know is that actually in the standard normal curve, and 0 is the This is standard normal curve. Then from minus 2 sigma to 2 sigma takes 95% of the portion, right? So again, since every normal curve is similar to standard normal curve, so if we find just from minus 2 sigma from the norm, from the mean, and plus 2 sigma from the mean, then this takes the middle 95%, right? And we know that here is the first, okay, I write down minus 1 sigma, minus 2 sigma, and minus 3 sigma, and here is sigma, 2 sigma, and 3 sigma. And if you calculate the mu minus 2 sigma, then it is 99, and mu plus 2 sigma is 191. So the range of study times that makes the middle 95% is from 99 to 191. Does it make sense, or do you have any question on this? Okay, then let's deal with the next question. So what percent of the students study more than 214 minutes, right? So here, 214 minutes, if you just change it in the G-score, then what you can get is, actually it is just mu plus 3 sigma, which is just 240 minutes, because 214 minus 155 is 69, but 69 is 3 times 23, which is sigma, right? So here, what we ask is just the what percent, oh, I draw this wrong. What percent of the students study more than 24 minutes? So it should be here, right? So therefore, and we know that from the standard normal curve, this region plus this region actually takes the 0.3%, because from negative 3 sigma to 3 sigma takes 99.7%, right? So we can just taking 1997 from the whole portion, then we need to divide it by 2, because we don't need this wrapped portion, right? So we already need this right portion, because we already care about the student more than 2100 per minute. So we need to divide by 2. Then what you can get is, yeah, 0.15%, because it is just 0.3% over 2. Does it make sense? Or do you have any question? Okay, then let's deal with number 3. What percent of students study less than 168 minutes? So here, 168 is just plus sigma, right? So it is mu plus sigma. So here is 168. So the percentage of the students study less than 168 minutes is just from the below to 1 sigma, right? And in this case, all we know is that this part from negative sigma to sigma takes 68%, right? So each part, about the mean, about the mean, each part takes 34%, right? And about the mean, the wrapped portion takes 50%, because it is symmetric, so the wrapped portion takes the 50%. So 50% from 68 over 2 is 34. So 50 plus 34 is 84, right? Okay, do you have any question? And next question is, what percent of students study between 99 and 122 minutes, right? So again, you can change it as a Z-score, then you can figure it out that 99 is actually mu minus 2 sigma here, and 122 is actually mu minus sigma. So this is from this orange colored line. And again, to get this, what we know is that from here to here takes 68% from minus sigma to sigma. And also from negative 2 sigma to 2 sigma takes 95%. So this orange region and this violet region, if you just add these two regions, then it takes orange plus violet takes 95% minus 68. So it is just 27%. But we don't need this violet region, right? Because we only care about this region from negative 2 sigma to sigma. So we need to delete this violet region. Then you can do it by just taking the half because it is symmetric, they are same. So if you just divide it by 2, then you can get 13%, 13.5%. Is it good? And next question is similar, that what percent of students study between 122 and 191? And again, 122 is negative sigma, mu minus negative sigma, and 191 is mu plus 2 sigma. So this region is this pointed by this red region. And again, we know that from minus sigma to sigma is known as 68%. And actually this, the remaining one is actually the violet region. But we know that this violet region and orange region is the same. And we already figured out that orange region takes 13.5%. So it is 68% plus 13.5%, which is negative 81.5%. Right. Okay. Do you have any question on this point 5? Okay, last question is a little bit tricky, but what study times that makes up the middle 50% of the student? And to figure out this, you need to, we learned about the quartiles, right? So from the first quartile to third quartile, and mean here, and our median here, which is called second quartile, and max here. So each quartile figure out how many percent they have. So this takes up the 25%, and this takes up to 25%. So they are the middle 50%. So to figure out the number of students, we need to figure out the quartiles of this graph. And from the previous lecture, we know that quartiles on the normal distributed curve is determined by Q1 is mu minus 0.67 times sigma, and Q3 is mu plus 0.67 times sigma. So if you calculate this, then what you can get is 129.59 and 160.41, and this is actually this light blue region, right? So the study times that takes in the middle 50% is from 129.59 minutes to 160.41 minutes. So that's what I want you to do in here. So when you see such a problem about asking you about the percent or probability of some regions in the normal distribution, then first thing you need to do is change your range, change your number into mu plus something times sigma form, right? Then you can figure out that maybe it is like mu minus something times sigma plus mu minus something, mu plus something times sigma or something. Yeah, you can get this kind of region. Then using this and your standard normal curve, you can figure out that which region is actually regarded to your boundary. Then using your standard normal curve, you can figure out the percentage or range of your regions, right? Okay. Do you have any question on this 9.4? Okay, so let's deal with negative 9.5. So in the 9.5, a class of 460 students will be graded based on the normal curve with a grade of A assigned to students who are more than 2 standard deviation over the mean. So which means that this grade is this students, region of this A student has mu plus 2 sigma to infinity, right? And grade of B assigned to students who are between 1 and 2 standard deviation above the mean, which means that it is from mu plus sigma to mu plus 2 sigma. And grade of C is student within 1 standard deviation of the mean, which means that it is from mu minus sigma to mu plus sigma. And grade of D assigned to students between 1 and 2 standard deviation below the mean. So it is mu minus 2 sigma to mu minus sigma. And grade F is students who more than 2 standard deviation below the mean. So it is from negative infinity to mu minus 2 sigma. Right? So, okay, do you have any question on this interpretation? So you can figure it out as a range of some, range in the normal curve. And the mean is 74, so mu is 74, and standard deviation is 11. Then using your normal curve, mean should be correspond to 74, and minus 1 sigma corresponds to 63, minus 2 sigma corresponds to 52, which is 74 minus 22, and minus 3 sigma corresponds to 41. And again, you can figure out the sigma plus 2 sigma and plus 3 sigma. Then we want to calculate how many students received each grade. So A is just above the mu plus 2 sigma. So A is corresponds to this region. So actually we know that from minus 2 sigma to 2 sigma, it takes 95%. So the remaining one takes, 2.5%, right? But we have total 460 students. So you need to multiply 2.5 with 460. And what you can get is 11.5 students, right? Does it make sense? Or do you have any question? Good. Likewise, B is from in between sigma to plus 2 sigma. So, okay, I just put it A here. And B is here with light blue. And again, we know that the middle from negative sigma to sigma takes 68%. So this right blue region is half of the 95 minus 68, which is 13.5. Okay, I write down it more clearly. Sorry for bad writing. But if you just multiply it with 460, then you can get 62.1 student. And in case of C, it takes the middle, 68% because it's from negative sigma to sigma, right? And we already know that from the standard normal curve, from negative sigma to sigma takes actually 68% of the portion. So you can just multiply 68% with the number of students, which is 460. Then you can get 312.8 students. And in case of D, you can do the same thing, but we know that actually this one, this violet one is the same as this light blue one, right? So the portion of B is the same as portion of D. So actually what you can get is the same student amount of here, 62.1, because we already calculated for B. And for F, yeah, again, there are no right. So, okay, in case of F, so this proportion is also same as A. So what you can get is just the same students of the A, right? So that's the symmetry, what I mean in A and F and B and D, right? Do you have any question on this example? Okay. Round up, yeah. So in this example, yeah, I just round up in the 1 decimal point. But in the actual exam or in the WebAssign, then they give you the specific instruction for roundup, so don't worry too much about that. Yeah. Okay, so the question is about the roundup, and in the actual exam or in the actual homework, they give you some special instruction about round the 2 decimals or 3 decimals or so on, so don't worry too much about the roundups. Okay. And do you have any other question? Great. And lastly, I mentioned in earlier, but okay, so in the chapter 5, probability is the same as portion, right? So if they ask you about what is the probability of that some students in some range of the grade, it means that how many proportions you have in all the students to get some grade, right? So there's no difference in the expressions. So please remember this when you solve your homework. And let's deal with the number 6. So in chapter 5, we deal with only one kind of data, right? So we deal with some numbers and we find its mean, median, quartiles, or mean and max, or something like that. But now we want to see how two data affect to each other, right? So for example, does the grade on exam 1 predict the grade on exam 2 in the class? Or does the temperature influence the number of ice creams sold in the market? But these are what we question about to get some information about the relationship between some object and the other object, right? So to find such a causation or relation, we need to figure out how these data actually have the same number, right? So first of all, we need to determine such a thing. We introduce some notation about the response variable and explanatory variable. Or sometimes response variable is called dependent variable, especially if you take some, science course, you heard about this. And an explanatory variable is called independent variable. So response variable is measure of outcome from some activity, especially from the explanatory variable. And explanatory variable that we think that this variable might cause changes in the response variable, right? So for example, let's see about temperature in the average temperature in car station and average daily kilowatt per hour of electricity, right? Usually in the home, in the car station. Then usually we think that when temperature goes up or temperature goes down, we use the air conditioner, right? So therefore, we usually think that temperature affects the electricity, right? So in this case, explanatory variable is, explanatory variable is temperature, and response variable is electricity, right? But sometimes it is not that clear. Maybe, especially if you're interested in about the environmental issue, then there are something called greenhouse effect or something. So it means that when we use air conditioners again or gasoline again, then it makes actually more CO2, carbon dioxide. So it makes our Earth much more warmer than before, right? So sometimes use of electricity actually affects your temperature on the whole city or whole Earth. So it is not that close whether this the relationship between two variables are just one is explanatory variable or one is response, or actually they are affect to each other, right? So to figure out this, first of all, we need to figure out at least whether they have some relationship between them. We say it is correlation, which we discuss in this class. And now after you find the correlation, then we can talk about the causation between two variables, or whether which variable is explanatory variable or which variable is response variable. But usually it is very difficult problem in the science, right? Okay, so to deal with the relationship between two variables, we draw a scatter plot which is just graph of two values with the explanatory variable on the horizontal axis. So if you know, in that case, we just put explanatory variable in the horizontal axis and response variable in the vertical axis. But if we don't know whether one is explanatory or whether one is response, then just put some variable you think that explanatory in the horizontal line, and the response variable, the variable you think that it may be response variable in the vertical axis, right? So scatter plot is just plotting all these points in the graph. So let's deal with the same data we deal with in temperature and electricity to find some relationship from the scatter plots. So here, to avoid this, I just start with 50, and since I might expect that temperature is the explanatory variable, so I will just think the x-axis is our temperature and y-axis is our electricity. And electricity starts with 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75. And temperature starts with 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, and so on. Then you can put the first point 86,76 in the when temperature is 86 and the electricity is 76, so it should be here. The graph is a little bit small, but yeah, let's do it. And next point is 85 to 70, so you can put it here. And the next point is 83,66, so we can put it here. So likewise, you can put those numbers in the graph. Okay. Do you have any question on this pointing out the graph? So let's do it next one, 77 to 38. So it should be maybe around here. And 69,26 should be here. Yeah. Okay. Do you have a question? Oh, okay. And 62,22, maybe, yeah, near the origin. And 55,25 is here in the grid. And 51,33 is here in the left side. And 52,30 is maybe here. And 61,26 should be here. And 71,38 in here. And 80,60 should be here, right? So when you finish your drawing the scatter plot, then first thing you can do is look at the overall patterns, right? So maybe from this, you can choose that actually, yeah, it looks like going this, right? So if you draw some quadratic line, then it appears, actually it is almost all points are actually similar to or near this line. So is the form is linear or not? That it is not linear. And the general direction is going to right opposite, but after, after temperature is 60, then it changes the direction to going to the left side. And how strong is the relationship? If you see the relationship, then it means that it is quite strong, right? But if you see there is no relationship, then it is not that strong. So these are the things you can figure out from your scatter plots, right? And lastly, also you need to figure out the outliers. So in this data, there is no outliers here because almost all points are very, near to the drawn line, but some data might have some outliers, and we can see this example in the below. Okay. Before going further, do you have any question? Okay, let's deal with this. So two variables are called positive associative. Yeah. Positively associated. If an increase in one variable tends to accompany an increase in the other variables, but two variables are negatively associated. If, oh, sorry. If an increase in one variable tends to accompany the decrease in other variables. So from here, in the example 1.7, in the left graph, first thing you can see is that actually you can draw a line which goes down when the x-axis goes increasing, right? So in this case, it says that it is, it is linear, but, and very strong because you can figure out the relationship, but it is negatively associated. Oh, sorry. So positively associated means that if increasing in one variable is increasing in the other variable, and negatively associated means that if one variable increases, then the other variable decreases, right? So it is negatively associated. And there are no outliers, right? Because there are almost all points are near the line. But in case of the right scatter plot, then again, it seems also, linear. And it seems very strong because you can see such a linear relationship. And you can see that when the variable increases in the x-axis or in the horizontal axis, then variable also increases in the vertical axis. So it is positively associated. But again, but here we have some outlier here, right? So if did you heard about the slope of the line? So if you heard about the slope of the line, then negatively associated is a scatter plot, which is linear, and the line has slope negative, right? But in the positive associated curve is scatter plot whose form is linear, but it has positive slope, right? So that's why we call it negative or positive in here. In the next example, in the third one, yeah, maybe you can draw this kind of line, but it doesn't make sense usually, right? Because even if you draw the line, but yeah, these data are just so dispersed so that it is not even close to these lines. So in that case, you can see that it is doesn't have any, yeah, no obvious relationship in here, right? And in the last graph, maybe you can draw this kind of line. So it is very similar to the temperature, the relationship between temperature and electricity in the previous one. But in this case, yeah, it seems very strong, but not linear, right? Actually, it is called quadratic in this case because it looks like the quadratic function. But if you don't know about the math, then do not need to remember it. So strong relation. So in this case, we cannot say whether this curve has positively associated or negatively associated because it is not linear, right? So positively associated or negatively associated is just the expression for linear relationship, right? Do you have any question on this? Okay, then now we call such a line we can find in the scatter plot as a regression line or regression curve, if it is a curve, but we usually deal with the scatter plot with linear relationships. So we just say that regression line, and it's a straight line that describes how the response variable changes as the experimental variable changes, right? So all we did in the draw in the previous example, these lines are all called regression lines. And you can actually figure out the regression line using the plots. So in the left case, okay, maybe your regression line drawing looks like this. But in the right case, your regression line looks like has negative slope. So definition 2.3 is about the positive and negative association. And again, you can figure out that the left one has positive association. And the right one has negative association, right? Do you have any question? Great. And let's deal with another example. So if you have some regression lines, what you can do is actually you can predict your value even if you don't have any data on here, right? So for example, in the left graph, we have a regression line which is given in the positive regression line in the left side. So here, and from this, when x is 8, then y should be, or y maybe it is around around 23, right? According to the regression line, because at 8, this regression line corresponds to 23, right? And if y, so okay, here is y, here is x. And if y is 30, then according to your regression line, it meets the regression line at x is equal to 40. So in this case, x is equal to 40. And lastly, if x is 2, then even if we don't have regression line at x is equal to 2, but you can extend your regression line like here, right? So maybe we can think that this line is just infinity goes. Then at the 2, it is near around 50, right? So it is around 15, right? Because this point is, it looks like here. So the one reason we draw the regression line on the scatter plot is that we can actually infer what kind of case occurs for next event, right? So if the next event occurs, and if you just measure the experimental variable and response variable, then without such a measuring, we can at least expect some value which is close to exact one, right? So that's why we find the regression line to infer the next event, right? Do you have any question? Okay, likewise, we can do the same example in the right side. So given the above graph, if x is 15, then y is maybe around 55, right? Because it is in between 60 and 50. And y is equal to 50, then if you just draw the line 50, then your x should be maybe around 16. Oh no, around 18 or 17. Maybe 18, right? Because it is slightly closer than 20, but not that close. So maybe around 18. And if x is 3, then again, we don't have regression line at x is 3, but you can extend your given regression line here. And when x is equal to 3, then it is almost around 72 or 73 something, right? Yeah. So in that case, for the first two cases of the question, we just use the existing regression line to input the variable, input the variable, right? But in the last case, x is equal to, we actually extend our regression line to the line which was not drawn, right? So in the first case, we call it as an interpolation. So interpolation is find the value between the minimum and maximum data values. So which is actually the regression line drawn in the variable. And extrapolation is just using the regression line to find values that are outside of the minimum and maximum values, right? Because in case of x is equal to 2, y is equal to 3 in the previous example, those are actually outside of the minimum value because the minimum value of x is at least 5 in the left one or right one in the, yes, x is 5 is the minimum value in the left or right graph. So x, the taking y value from x is equal to 2, y is equal to 3 is actually doing extrapolation. Or previous two questions, when x is equal to 8 or y is equal to 30, and these are actually just input the value which is in the existing regression line. So it is called interpolation. Do you have any question? Good. Okay, so now we know how to draw the regression line, especially approximately, and also we know, the relationship, whether it is linear or quadratic or something like that. But sometimes you can ask that about this line. So for example, just see this example first in the left top side. So in this case, almost all points are near the regression line. And so it is linear but negative. But in the right side of this example, then yeah, it is also same negative association regression line, but now these points are actually dispersed much more bigger than the previous one. And in the last example, again, here points are dispersed much more bigger in the compared with the first one, right? So in that case, sometimes people ask how much this regression line actually explains the data, right? So to explain this, we just adopt the concept of correlation, right? So the correlation, which is called usually R, it measures the direction and strength of the straight line relationship between two quantitative variables. So this correlation has from -1 to 1. And if it is close to 1 or -1, it has the strong relationship. But if it is close to 0, then it doesn't have a strong relationship. Maybe if you see the pictures, then it is much more clear. So in the red top picture, it has -0.9 correlation, which means that it has strong relationship, but but this relationship is negatively associated, right? But in the right bottom picture, it has correlation 1. So in this case, it has not only having a strong relationship, but also this has positive association, right? But when you see the case when R is equal to 0, then you can see that it is just, just points diverse in every year. So in that case, we don't have any specific relationship, right? And also, if you just compare when R is equal to -0.5 or positive 0.5, then you can see that actually those are or have a linear relationship, but not that strong compared with the wrapped graph or compared with the graph scatter plot in R is equal to 1. And so this correlation measures how much your relationship in the scatter plot is strong than usual one, right? So can you have any question on this? So in this course, we do not require to find correlation itself because it takes a little bit longer time and we need to explain to how to get this. But what we want to do is that when you know the correlation from the data, then we want you to interpret as a graph or some pictures, right? So for example, so when you have two scatter plot with one is correlation 0.7 and the other is 0.9 but negative 0.9, then which represent the stronger linear relationship? The first one or latter? Pardon? The negative one, right? Because in their absolute value is 0.9, which is greater than 0.7. Thank you, Dawson. So yeah, so in this case, the latter has strong linear relationship. So these are actually important for you because, okay, do you have a question? Yeah, it is negative, but negative means the direction of the linear relationship. So negative means that it has negative associations. So its linear relationship looks like this. But in case of positive, linear relationship looks like going opposite. Does it make sense? Great. Okay, good. Okay. So, yes, so in this course, and actually in the real world, it is much more important to interpret your data instead of doing this, because usually all calculations are done by computer. So you don't need to, know the formula, in my opinion. But it is very important to figure out that if you see such a statistics, then you need to interpret the relationship between the data. So that's why we skip the least scale regression. So yeah, actually when I draw the regression line, I just draw it, very barely. I just approximate some regression line, but there are something called least scale method, which is actually how to draw such a regression line more precisely in mathematics. But we didn't deal with this method. But if you're interested in, then please let me know. Then I will help you to understand this method. Actually, yeah, if you're interested in math, then this is one of the coolest facts in the mathematics, but I do not deal with it in the course. Okay, so let's deal with section 5. So I just want you to know how to interpret this correlation and regressions. So first thing you can do is that actually, if you have small number of data, then outlier affects your regression line a lot. So see this line. So see this the data. So maybe your data are in the website, right? And if you have one outlier in the upper bottom side, then your regression line actually have the positive association. But when your outlier actually goes down, then your regression line actually affected by outlier. So it has some negative associations, right? So if you just get rid of this outlier, then what you can see is that actually there's no some obvious relationship. But if you have some outlier out there, and if your sample is very small, if the data is very small, then yes, sometimes regression line was affected by outliers. So in this case, you need to figure out that whether your data is enough to draw the regression line or not, right? So yeah, so that's the first thing you need to running. Have some, care about when you interpret your data. Do you have any question on this? And next one is about when extrapolation is usually seems much more, is much more suspicious than interpolation, because sometimes, there are some data which have different behavior in near the end. So for example, think about the example 5.1. So study says that children aged 2 to 12 years old found a growth rate of 2.5 inches per year. So which means that actually, yeah, after 1 year, your height grows 2.5 inches. So if Jane was 48 inches right now at age 12, how tall we should be at age 13? So if you just extrapolate the data, then, at this, actually to make Jane be age at 30, Jane should live at least 8 years, right? And we know that growth rate is 2.5 inches per year. So if you just extrapolate your data, it means that you can just add those growths in your current height. So this is height current, and it is growing height. So if you just calculate these numbers, then what you can get is 2.5 times 18 is 5 times 9, which is 45. So 45 inches plus 48 inches, which means that it is 93 inches, or 7 feet 9 inches, right? But yeah, but can you see that? Does it make sense? Really? Is there anyone whose height is growing even if you are in 20? No, right? Not that much, but yeah, there are someone here, but not that much usually especially in case of the human, our height is actually determined at the 20 or 25, and you do not grow like you're in teenagers, right? So yeah, even if it makes sense in the math, but it is not that makes sense in the real life, right? So that's why we need to be careful about extrapolation of the data, right? So it makes sense as a math, but not real, right? Because we know that heights are not much after 25 years old, right? After age 25. So that's why we need to be careful when you interpret your data or in math, right? So you need to use your background knowledge to interpret your data, and especially when you extrapolation your data, you need to be careful about your background knowledge. So is there any question on number 5.1? Okay, next one is about the US population. So in the 1960s, the US population was this amount. So it is 180 million. But annual growth rate at the time is 1.7%, causing alarm about the overpopulation. So in the 50 or 70 years ago, yeah, they have some concern about how many people live in Earth. So they think that maybe population actually explode too much so that we don't have any much environment to share them. But if this rate continues, then one US can be is actually this number is not the same. So you don't need to remove this number, but I just want to explain how can I get these numbers. So if you see that our growth rate is 1.7%, then it means that at every year, 1.7% of the population is growth. So you need to multiply 1.017, which is just 117%. And we just multiply 50 times because in every year we grow like 1.7% for each population. And what you can get is this number. But actually, when we just live in the 210 and by US census, we can see that actually US population is almost 300 million. So it is definitely, not the same as this number, right? Do you have a question? Pardon? No, in this case, yeah, if the growth rate is 70%, then you are right. But in this case, growth rate is 1.7%, right? So that's why 100% plus 1.7. So 101.7%. Does it make sense? great. Okay. Do you have any other question? Right. So that's one of the example about the be careful on extrapolation. And the last one I want to explain is that correlation does not mean causation. Actually, that's the important one. So first example is that a study claims that chocolate consumption enhances cognitive function. And the reason they claim is that there is some positive correlation between the country's chocolate consumption and the number of countries who won the number of people from that country who have the one Nobel Prize, right? So maybe chocolate consumption affects the Nobel Prize ability, but so it's a little bit, we don't know, right? It's just correlation. And we don't know the exact one, and we still don't know how chocolate consumption affects someone's cognitive functions, especially someone in the, in the research fields, in their cognitive function to get the Nobel Prize. So, and also there are some other factors maybe affect on this relationship. So it is a little silly to argue that chocolate consumption actually enhances cognitive function because of that fact, right? So this is the case when the study actually think the correlation as a causation, but it's not, right? So that's one example. And the other example about this is that one of the studies shows a strong correlation between increasing in organic food sales and increasing of the number of people diagnosed with autism, right? So does this mean eating organic food cause autism? May not, right? So usually, especially, autism and organic food sales are grow when people's population is growth, right? So maybe they are all affected by just population growth or any other factor because we don't know whether organic foods occurs autism or not, or maybe autism makes people to love the organic foods or not. So we don't say about that causation between two variables, right? So that's another important example about the causations in here. And the last three, actually, if you are interested in this subject, actually, I just want to recommend some book. It is not my books. It is not commercial recommendation. So it is just some very, recent work on Julia Pearl, who is in UCLA. So especially, if you just learn about the statistics more, then they deal with about the correlation, right? But we don't have much tool to use the deal with causation. And recently, Julia Pearl and there are some, colleagues actually build some knowledge and some methodology about how to figure out between correlation and causation. And Book of Why is just a book without any math, formula, right? So it is just introduction book for such a method. So if you're interested in about such a causation things, then I think that it will be definitely helpful. And it contains a lot of the, recent cutting edge argument. So maybe it is helpful for you to serve it, right? Especially when you are interested in statistics. Okay. So the next homework due is this Saturday. So chapter 6 homework due is this Saturday. So don't worry too much about that. And let's call it a day today. And thank you for listening. And if you have any question, please let me know. Good day. Okay, do you have any question? Then I will close the Zoom session. If you have any question, then please let me know because my office open starts from 3 p.m. to 4:30. Thank you very much.